In this video, we're going to talk about solving right triangles and using sine, cosine, and tangent, which takes me to our first blank down here. Probably things you've heard of before. Our goal is to take basically two bits of information in addition to the fact that we have a right triangle. So we definitely have a 90-degree angle. If you look at these two triangles, we're going to always have a 90 here. And if you are given two of the sides or one of the angles in one of the sides, then you should be able to solve the rest of it. You should find all missing sides and missing angles. And trigonometry is what allows the angles to get involved. You should already have been able to find missing sides given the other two sides. That's the Pythagorean theorem. You've probably known about that for a couple years now. But trig is really when the angles start getting involved. So that's our goal, to find missing parts of right triangles using sine, cosine, and tangent. Just a little background, these are ratios. And what that means is we're not necessarily, sine, cosine, and tangent are not concerned with the size of the triangle in terms of the lengths. So you could take two similar triangles, like, keep it simple, we could take a 3, 4, 5 right triangle, and if we double that to a 6, 8, 10, these are two similar triangles. It's just one of them's been enlarged. So when I say sine, cosine, and tangent are ratios, what I mean is, let's take this angle down here, which is the same as this angle right here, and if you were to type something in your calculator like sine inverse of sine is opposite over hypotenuse, so sine inverse of 6 over 10, what you are asking your calculator for is what's this green angle down here. And if you type sine inverse of 3 over 5, obviously you're going to get the same thing because 6 over 10 and 3 over 5 are the same thing. So when I say it's a ratio, it means it doesn't matter if we're talking about the bigger version of the triangle 6 to 10 or the smaller 3 to 5, you're going to get the same angle. If you type both of those things into your calculator, you're going to get the exact same result. Make sure your calculator is in degree mode, by the way. Your calculator should have radians in degrees. On my TI-84, if I hit mode, kind of near the top of my options, I have a radian and a degree option. So whatever calculator you're using, make sure you're in degree mode before you do anything like this. Okay, so let's see how we can use these ratios to solve right triangles. Okay, so our first goal is to find missing sides. Now, you've found sides with, like I said, the Pythagorean theorem, but now we are given one side and one angle, and we want to find the missing side. So the first thing you need to do is choose a ratio based on what you have and what you need. So I have the opposite side, meaning if I go to the 59, the 22, the number I have, is opposite of the 59. All right, when you first learned about sine, cosine, and tangent, you learned about opposite, adjacent, and hypotenuse. I need the hypotenuse. All right, the hypotenuse is always across from the right angle. So I want to use the trig function that involves the thing I have and the thing I need, and it's sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent. Probably, again, something you've heard before. I've heard this way to remember that. Some old hippie caught another hippie tripping on acid. Not entirely school appropriate, but that's how you can remember the SOHCAHTOA. Sine equals opposite over hypotenuse. So I need hypotenuse, I have opposite. So that means use the one with the O and the H. So I'm going to say the sine of 59 degrees equals opposite 22 over hypotenuse x. Okay, so then I need to solve this equation. If your x is in the denominator, basically what's going to happen here is you're going to switch the sine 59 and the x. That's really two steps in one. I'm multiplying both sides by x, and I'm dividing both sides by sine of 59. And this brings up a point. Sine of 59 is one, it's actually just a number. If you type sine of 59 in your calculator, it is, again, make sure you're in degrees, it's 0.85716, like it's a decimal, long decimal that gets rounded off on your screen. But sine 59, when you're working it around in an equation, it needs to move around as one item. So I'm going to do x equals 22 over sine 59. And I'll type that in and go 22 divided by sine 59, and I get 25.7. Let's round it off to 25.7. Now, I encourage you in all of these style questions and all this triangle work we're getting ready to do, look at your triangle and see if it's reasonable. 25.7, is that a reasonable length for this x right here? I can't look at that and know it's exactly 25.7, but it's reasonable. It's the hypotenuse. It's got to be longer than 22. And if I just look at my scale, it's in the ballpark. You can catch a lot of mistakes that way. You won't necessarily know it's perfect, but if it had come out, for instance, less than 22, then you know it's definitely the wrong answer. All right, so one more example for finding a side. I'll try to make this one a little quicker. From this 23, this is adjacent. It's right next to the 23. Opposite would be over here. I don't have opposite, I don't need opposite, so I'm going to use the trig ratio that doesn't have any opposite in it, which is cosine. Cosine of 23 equals adjacent, which is x, over hypotenuse, which is 101. And this style is a little easier to solve because all I need to do is really move the 101 over here and do 101 times cosine 23. 101 cosine 23 is 92.97. And again, look at it. Is it reasonable? Sure. The hypotenuse is 101. This longer leg is, in the ballpark of that hypotenuse. It's a little shorter, but 92 makes sense. All right, so that's finding sides. Let's find some angles. Okay, so here's the big difference. We're going to know the sides. We're going to know a pair of sides, and we need to find a missing angle. So on this first one, well, actually in all of them, we're going to use inverse trig to solve these. So on this first one, look at the angle we have over here is x. This is opposite, 25. This is adjacent over here. I don't have the hypotenuse. I don't need the hypotenuse. Hypotenuse is not involved. I could find it with the Pythagorean theorem if I wanted to, but use the numbers you're given, right? So this is a tangent. Tangent of x equals opposite 25 over adjacent 17. Okay, so now, if I had given you, if you had x plus 4 equals 10, what do you do to both sides? Minus 4, minus 4. Some solid algebra 1, right? The reason you use minus 4 is because that is the inverse operation of plus 4. Those two things wipe each other out. Okay, we could do the same with multiplication and division, or square and square root, or exponentiation and log, whatever. Well, the inverse of tangent is just called tangent inverse. So technically what happens at this point is I'm going to tangent inverse both sides. Eventually you won't think about this process in this much detail, but that's what's happening to both sides. The reason I tangent inverse both sides is because just like plus 4 and minus 4, tangent inverse and tangent completely wipe each other out. They're inverse operations. All right, it's just that with inverse trig, we don't have a new fancy name for it. We just call it the same function, but with inverse. All right, so tangent inverse of 25/17. I'm just going to type that in my calculator. Now, tangent inverse on my calculator is second, then tangent. Again, I'm making sure I'm in degrees. I don't have to change it every time, but make sure you're in degrees before you type one of these in. And when I type tangent inverse of 25/17, I get 55.8 degrees. Okay, the answer to a tangent inverse is the number of degrees. So it's saying if you have a triangle with a 25 and a 17 in this arrangement, then that angle right there must be 55.8 degrees. All right? So there's the difference. When finding angles, use the inverse trig. You might want to jot that fact down. When you're looking for angles, you're going to be using inverse trig. All right, and one more. Find the missing angle. What do I see here? I see the opposite. I see the hypotenuse. There is nothing over here for adjacent. So I'm going to use the trig function with no adjacent. So katoa, SOH, sine equals opposite over hypotenuse. So sine of x equals 30 over 33. And before I start, I'm going to think, what kind of angle is this? This is a pretty big angle. It's less than 90, but it looks like we got a little sliver of an angle up here. We've got a smaller or a big angle down here. So I'm guessing it's going to be something in the 70-degree range. I have no idea if that's correct, but I like to have a number in mind, so I'm always thinking about whether or not my number is reasonable. So I want to do sine inverse of 30 over 33, again, because that's what wipes out sine on the left. Sine inverse, second sine, 30 divided by 33 is 65.4. And I was thinking something in the 70-degree range, so that's reasonable. Okay? So that's how you find angles. Use inverse trig functions to find angles. Now I want to wrap it up with this solve the triangle. When the directions say solve the triangle, what that means is find all the missing parts. That should be three things, because we know there's a right angle, and you have to be given two bits of info, either two sides or a side and an angle. You won't be given two angles in addition to the right angle, by the way, because that doesn't define a triangle. That could be any size, right? That could be just two similar triangles with the same angle. So you'll at least have one side and then either another side or an angle. So when we solve this thing, what will happen is you'll have lots of options on methods you could do, on ways you could solve, and that just gives you ways you can double check. I don't have a lot of options at first. I could find either little a or little b. By the way, when you name sides, a common way to name them is the lowercase letter that corresponds to the uppercase letter. So I would say 14 is little c. That would be the name. It's always the same letter for the angle and the side across from that angle. We'll see a lot of that this unit. Okay, so let me find, I'll find little a first. I'm going to use the 31. So if I'm looking for little a, I can say that tangent of 31. Think about, why did I choose tangent? Because I have the opposite, I'm looking for the adjacent, and tangent is TOA. Tangent of 31 equals 14 over little a. So basically a is 14 over tangent 31. Again, this is one of those little switch, two steps in one. I'm going to multiply both sides by a, which brings the a up to the left. I'm going to divide both sides by tangent of 31, and little a should be 14 divided by tangent of 31, which is 23.3. And is that reasonable? So I'm looking at see that 14, this side should be considerably longer than 14, so 23 looks reasonable according to my picture. Okay, so now moving along, what else do I need to find to solve the triangle? I've got, A is good, so I've got little b and big A. By the way, big A, that should be easy to find. Big A, let me write some proper terminology here. The measure, little m, angle A, that's the measure of angle A. That should just be 180 minus 90 minus 31. I don't really need trig for that one. I'm just using the old 180 rule from geometry. 180 minus 90, I could just do 90, minus 31 is 59. So I would say the measure of angle A equals 59 degrees. So there's two of the things I needed. So that just leaves me with little b. So let's talk about options here. How could I find little b? Well, now that I know two sides, I could do Pythagorean theorem. I could say 14 squared plus A. Now that I know A, 23.3, and I could use all those decimal points from my calculator to keep it more accurate, equals B squared. All right, once you know A, you know two sides, and if you know two sides, you could find the third side. I could use angle A that I just found. I could use some trig function with angle A. I could use angle C. I could have found B at first. Instead of using tangent of 31, I could have used, let's see, sine of 31 equals opposite over hypotenuse, which is 14 over little b, and solve there. So that would be 14 divided by sine 31 would be 27.2. And again, that's the hypotenuse, so B equals 27.2. If you do this Pythagorean theorem, by the way, I'm going to do 14 squared plus, and that 23.3, I'm going to reach back up in my calculator and get that number and square it. Add those, square root, and I get B equals 27.2. No surprise. I just want to show you that you have options. Now I'm going to make a suggestion. I would suggest that this option is better for this reason. I used in this option only numbers that were given in the question, so the 14 and the 31, right, to get my 27.2. I got the correct answer here with the Pythagorean theorem, but I had to use this 23.3. Now, because that 23.3 was correct, I got the right answer. But let's say you had made some sort of mistake or typo finding that 23.3. If this is wrong, then this is wrong, which makes this wrong. So my advice is to use the given numbers as much as possible, because you know they're right, and if you use numbers that you found, any small mistake makes your next question automatically wrong. So that's just an advice. But if you're right on your first one, if you're right on little a, then you would be right on little b too. So that's just an option for you. But solving a triangle means finding all the missing parts, and the specific focus here is sine, cosine, and tangent. Once angles get involved, help you solve missing parts of right triangles.